Hi, my name is Kylie Valeni, and I'm going to be teaching about halftime. After an amount of time, an exponentially decaying quantity with a half-life decreases in size by half. The formula used is new value equals initial value times half raised to the t divided by t half. The t stands for after a time, so it is the time we will be using in the equation. T half stands for the half-life, and the initial value is when a certain value of something is stated. So an example of that is 100 pounds of plutonium. In our homework problems, there will not be initial values, so we will be focusing on the fraction part. The questions we will work on and answer are numbers 41 and 43 on page 490 in the textbook. Number 41 reads, the half-life of a radioactive substance is 50 years. If you start with some amount of this substance, what fraction will remain in 100 years? In 300 years? So we use the formula and substitute in the values from our problem. The problem states that the half-life of the substance is 50 years, and we need to find what fraction would be left after 100 years and 300 years. 100 and 300 equal t. We will set up two separate equations, one using 100 and one using 300. So as you can see, I used the formula from above and kept the 1/2 and then substituted in the t and the half-life. The first one we used 100 as the t, and the second one we used 300 as the t. Now we will plug these into the calculator to figure out the answer. So the answer to the first one is 0.25 or 1/4. And to put this answer into fraction form, you can click the math button and then enter on the number 1, which stands for fraction, and that will turn the answer into a fraction, which is 1/64. So as you can see, after 100 years, there will be 1/4 of the substance left, and after 300 years, there will be 1/64 of the substance left. And that is all for number 41. Number 43 reads, the half-life of a drug in the bloodstream is 18 hours. What fraction of the original drug dose remains in 24 hours? In 72 hours. So again, we will set up the same equation by substituting in the numbers that were given in the problem. So the first t we will use is 24 hours divided by the half-life of 18 hours. And the second equation will be 1/2 raised to the next t, which was 72 hours, divided by the half-life of 18 hours. And then we will plug that into the calculator. And that is that long decimal, so we can round that to approximately 0.4. And then for the next part of it, and that decimal 0.0625 is the answer there. So after 24 hours, there's approximately 0.4 left of the substance in the bloodstream. And after 72 hours, there is 0.0625 of the substance left in the bloodstream. And again, if you would want to put those answers into fraction form, you would push the math button and then enter on number 1, which is fraction, and enter again, and it gives you the fraction form of the answer. So overall, to figure out half-time, you use this formula and you plug in numbers for t and t half, which are the time and the half-life, and initial value if it would state it in the problem, and then use your calculator to find those values.